Okay, so this video will show you the steps to solve the test of normality, that is Kolmogorov-Smirnov test, by using SPSS. We are taking here an example. A researcher reported that the total time per week in hours for 30 college students spend their time on surfing internet are shown as we have to feed data first here that will be assessed by the Kolmogorov-Smirnov one sample test, and the null hypothesis that these data came from a normally distributed population. Then we go to the hypothesis that the sample population is normally distributed. So now we have opened SPSS, and here in this data view, let me feed the data first. Okay, so in variable view, we label this as time and make sure this data is in ordinal scale. Now we'll go to the data view. Here, as you can see, here are the 30 subjects. Now go to the analyze, then descriptive statistics, and then to click on explore. We choose time and put it on the dependent list. Now go to the plots and mark histogram, unmark this. You can go for the none for box plots and tick mark on this box normality plots with test. Click on continue, and in statistics, yes, everything is done, 95% confidence interval, and descriptive statistics. Continue. Now you have to click on OK. Okay, we have to wait here and okay, here we get the result. So this is the descriptive table, test of normality, and here we got the histogram. We have here skewness and kurtosis. To determine this data normally distributed, we check by looking the values. If their two values are approximate to 0, we can say that this data are normally distributed. So from our result that we got, kurtosis is 0.065, which is approx to 0. Sorry, the skewness is 0.065, which is approx to 0, and the kurtosis is minus 0.9, which is also approx to 0. So from this result, we can say that this data is normally distributed. Now comes to this table, test of normality, which we have two tests, that is Kolmogorov-Smirnov and Shapiro-Wilk. So here we can see the both the significant difference that we got from the both tests. Let's look at this table and the test, which is also known as Kolmogorov-Smirnov KS test. Column will look at the statistic, DF, and significant value to make sure that this data is normally distributed. So the significant value, this I've highlighted it. So the significant value must be greater than 0.05. So from this result, we got 0.2. So we can say that this data is normally distributed. Here also we can compare like in Shapiro-Wilk 2, the value comes 0.506, which is greater than 0.05. So we can say that the data are normally distributed. And if we can see this histogram, uh, here is time and the frequency. So it's more like a bell shape. So this is normally distributed. So in this, we do not reject the null hypothesis. Thank you.